Let's look at 2.1.2. They say here, determine the value or values of x if the sequence is geometric. What do you know about a geometric sequence? Or what can you identify a geometric sequence with? The geometric sequence have what we call the common ratio. And the question again is, how do we find the common ratio? So we say to find the common ratio R, we use the formula T2 over T1, which must be the same as T3 over T2. Now let's check this. What is term number 2 here? Term number 2 from the sequence is equal to x from this given sequence here. Term number 2 will be x, so we write x over the first term here will be 4. So it is x over 4, which is equal to term number 3 is 32, so we write 32 over term number 2, which is equal to x. Now from this, we can solve for x. Because we have one term on the left, and we also have one term on the right, we can cross multiply. In other words, we can say here, x multiplied by x, and that will give us x squared. And then after that, we say 4 multiplied by 32, and that will give us 128. But please make sure that when you do this, you use your calculator. And then to find the value of x, we will then apply the square root on both sides. And the square root will take care of the square, and therefore your x will be equal to plus or minus the square root of 128. It will be plus or minus the square root of 128. Then you can simplify this and leave your answer in set form. So the most important thing that I wanted to indicate with these two examples was that if you are told that the sequence is arithmetic, then the sequence must have a common difference. And again, if you are told that the sequence is geometric, it means the sequence must have a common ratio. So if you are not given a sequence as clear as the ones that we normally work with, like this one, where you will have to calculate the value of the variable, then you can use that fact to say, because the sequence is geometric, T2 divided by T1 must be the same as T3 divided by T2. So that is the first example that I wanted us to look at. Now let's take another example. Let's take another example. Now I want us to look at question 3 now. Question 3. Question 3. Let us look at this question 3. They say here, the following sequence is a combination of an arithmetic and a geometric sequence. They are talking here about arithmetic and geometric sequences. Now, but here we are given the combination. So we have 3, 3, 9, 6, 15, 12, and so on. So they said it is the combination. Now let's look at this combination here. They said it's arithmetic and geometric. So if we take it like lightly, we can say 3 minus 3 is 0, 9 minus 3 is 3. I mean, it's 6. It does not give us the common difference. Again, if we say 3 divided by 3, it gives us 1. 9 divided by 3, it gives us 3. It also does not give us the common ratio. In other words, this combination cannot be a successive combination. Like, for instance, arithmetic sequences first and then geometric sequences. But when you look at 3, 9, and 15, and you check with arithmetic first. 9 minus 3. This will give us 6. And if you say here 15 minus 9, it will also give us 6. Which means from this one can see that 3, 9, and 15 give us what we call arithmetic sequence, because we have a common difference of 6. And again, when you look at the remaining terms, we look at 3, we look at 6, and we also look at 12. Because they talked about the combination, and we already have arithmetic sequences, we are going to test for geometric. If we say here 6 divided by 3, if we say here 6 divided by 3, it gives us 2. And again, if we say 12 divided by 6, 12 divided by 6 also give us 2, which means the sequence 3, 6, 12 is a geometric sequence. So indeed, we have a combination of arithmetic sequence and a geometric sequence. Now that we are able to identify that combination, let us look at the first question. The first question says, write down the next 2 terms. Now going back to our combination of sequences, the first term is the first term of an arithmetic sequence. So for us to move from 3, remember, we add the common difference, and the common difference here is 6, which means we are going to have 3 plus 6, and that will give us 9. And then 9 plus 6 will give us 15. And 15 plus 6 will give us 21, which means the next term here, the next first term is going to be 21, looking at arithmetic sequences. And when we go to the second sequence, which is geometric, the common ratio, we found it to be 2, which means to get other terms of the sequence, we are going to multiply each term by 2. So when we multiply 3 by 2, it will give us 6. And then 6 multiplied by 2 will give us 12. So we move from 3 to 6, from 6 to 12. And then we multiply here by 2, and then we also multiply here by 2. So we multiply this 12 here also by 2, and then it will give us 24, which means the next 2 terms that they are talking about here, the next 2 terms that they are talking about here will be 21 and 24. That is how we find the next 2 terms. If you look closely at what I have done here, you would realize that first, I had to identify which numbers represent the arithmetic sequence. And because it is arithmetic, I then used the fact that you add 6, which is the common difference, to the previous term to get the next term. That is how we got to this 21, because we added 6 to this 15 to get 21. And with geometric, because it has a constant ratio, we multiplied the previous term by 2 to get the succeeding term, which is equal to 24. And that is how we find the next 2 terms. I hope we are enjoying this up to now.